we can just start while waiting for more people. Um, so again, thank you everyone for joining the call today. I think it's been very hot in Vietnam at this stage. I'm not sure about Edinburgh. Maybe definitely much better, than the weather that we are having here. But we're in the middle of summer, and today definitely we're gonna talk about something pretty, which is gonna help us to cool down, the temperature hopefully. So we're gonna learn a few cool things about Mina and I don't know, Snarky.js and ZK possibly. I think that's some of the expectations from the audience. So it's my pleasure to co-host the session today with Phuc from Sotatek. So we are hosting this as APAC DAO and ABC Station, which is a developer-focused initiative in Southeast Asia. And of course, we cannot, we also have Angus from Mina Foundation, who is going to be the protagonist, the main character for our session today. So maybe I'll leave it for Phuc to introduce a bit about yourself, and then Angus, and then we can just start the session.
Yeah, thanks, Nicole. Let me introduce myself first. So I am Phuc. I'm the co-founder of Sotatek. At Sotatek, we are the leading Web3 development company in the region. We house over 1,000 employees, and most of us are crypto engineers. So we also incubate many projects coming out from Vietnam too. So today, I'm very excited to speak with Angus here about building on Mina protocol, the latest blockchain using zero-knowledge technologies. Yeah, over to you, Angus.
Hello, everyone. Thanks for the introduction, Phuc, and also thanks for having me here, Nicole and everyone from APAC DAO. Now, I'm just going to start my timer here, just because I don't want to run over time. I'm going to talk to you today about Mina protocol and Snarky.js, which is the TypeScript library that you can use to build apps on Mina protocol. So, as a little introduction to me, my name is Angus Maidment, and I do developer relations for the Mina Foundation. And so I'm based in Edinburgh in Scotland. We've got a rare kind of glimpse of good weather at the moment, but it usually doesn't last long. It rains a lot here, and it's cold and windy and miserable most of the time, but sometimes it's okay in summer. So you can follow me and what I'm up to and find out more, get updates on things that are happening with Mina on Twitter. My Twitter handle is blockchainbeard. So there's also a photograph of me kind of wearing the hoodie and trying to blend into the sign here at an event that we did. I can't remember which one. So today I'm going to run down Mina, introduce you to the Mina protocol and how it uses ZKPs or zero knowledge proofs. We're going to talk about ZK apps, which are the applications that developers can build that use the zero knowledge cryptography that Mina makes available for you. Snarky.js is the TypeScript library that you use to write these apps in. And then at the end, I will talk to you about ZK Ignite, which is a funding and kind of accelerator program that we have that we run, and also some other kind of updates and next steps. So the first section, I'm going to introduce the Mina protocol and tell you about zero knowledge proofs. Some of you on the call may know a little bit about zero knowledge proofs and what they do, but if you don't, a zero knowledge proof is a cryptographic tool. It uses cryptography to you can prove things and you can verify information in a private, trustless, and decentralized way. So that is useful for a number of use cases. There's a few examples on this slide. So you can do things that give you a lot more scalability and privacy. So things like ZK rollups and ZK EVMs using zero knowledge cryptography to provide those functions. You can use them for doing things like private transactions and voting. Obviously, identity is a very important thing, especially digital identity in the age of the internet and apps and electronic ways of doing things. So ZK identity, choosing when and where to reveal information is going to be a big use case for zero knowledge proofs, we think, and also verifying large scale computation. So a zero knowledge proof essentially allows you to say, I have run this program that I've written, and with some certain inputs, and then you can check that proof that I've generated. You can check it efficiently, so it's fast to verify, and it says here constant time, which is a technical term, and you can do this without seeing some of the inputs. So there's this concept of having private inputs. So you can keep some of the input private, you can prove that you've run a certain program and that it's given you a certain output. So that allows you to provide scalability, it's good for verification, and also privacy and security. So this slide here, just to say as well, I will make these slides available for you after the event. So if you want to look over them, some of them have quite a lot of detail on them. You'll be able to get hold of them afterwards, and you can look over these things that have a bit more detail in them. But this slide basically lays out some cryptographic primitives or things that you might be familiar with as a developer, and compares them or introduces the what like a zero knowledge proof looks like next to them. So a hash function is a function that takes in a string and then it outputs a fixed length string, right? But it's a unique identifier. Oh, well, not unique, but it's if you put different data in, you'll get different data out. So you can say this data corresponds to this hash. So then someone can tell if someone else has given them different data because the hash will be different, right? So hash functions can say that these two pieces of data are equivalent by using the hash. And you might be familiar with public key signatures, which is saying that if you own a private key, you can sign some data, or as it's called here, a message. So you can produce a signature, and then someone else can take your public key that corresponds to that private key, and they can verify that signature. So they can verify that you have signed something with your private key. So in that way, you know, if you have a developer, they can sign packages with their private key, and you can verify that it's the actual, you know, software that this developer has released by using the public key to verify the signature. Now, a zero knowledge proof lets you say, I'm going to create a computer program, and then when you compile that in using it in Mina, you can use the compiler for your program to generate something called a verification key. So that's a string, and that verification key can allow someone to verify a proof. So you compile the program, then you can generate a proof. So anyone can use your program, right, to generate a proof, right? So they can put in some public inputs, some private inputs into your program, and that generates this proof. And then the verification step is that someone can verify this proof using the proof as an input, the public inputs that you put in when you ran the program, and the verification key. So the key points here are that once you compile the program, anyone can generate a proof, and anyone can verify that proof using the verification key. Also, another important aspect is that you can keep some of the inputs private, and to verify the proof that you've created, all the verifier needs is the public inputs and the verification key, and obviously the proof that you generate. So as you can imagine, you can prove that you know something, or that you have a solution to a puzzle or something, without having to reveal the actual solution. So I've alluded to it before in what I've said, but Mina protocol is a layer 1 blockchain that's built entirely using zero knowledge proofs. So the blockchain protocol works using zero-knowledge proofs to prove a lot of things. And indeed, you may have heard that Mina has a very small state size, and that is actually due to the fact that it's all zero-knowledge proofs, which are kind of combined and into this one very small state proof, which is fast to verify. So what does it mean that it's a zero knowledge, the blockchain is built using zero knowledge proof? It says here efficient verification and interoperability. And so one of the things that zero knowledge, the way that Mina is built using zero knowledge proofs, one of the things that means is that you can verify the blockchain in a lightweight way with very little data and not a whole lot of computing power. So on the left-hand side there's an image that shows a desktop, a tablet, a mobile, a laptop. So you can verify the state of the Mina blockchain with like a mobile device, right? And that is because these lightweight proofs are very fast to verify. It also is interoperable in the sense that you can execute computation using Mina. So you can use, you can write a ZK app using Snarky.js. You can run the computation, you can run the program, and you can create a proof that you can then verify quickly on other blockchain networks. So for example, you could run a massive computationally intensive ZK app on Mina. You could generate the proof. And then if you put that proof onto the Ethereum network, so for example, you have a smart contract on Ethereum that takes in the proof from your computation that you've done on Mina and verifies it, then you can make decisions, you can execute logic on Ethereum using the output or the verification of things that you've done in your ZK app. So in that sense, you can, so this concept is you run the computation using Snarky.js, and then you can verify its results on other blockchains, because all you have to do is verify this proof, which is a fast operation, and it doesn't take a whole lot of computational resources. So these aren't things that we are just kind of talking about. This is something which is currently being worked on. So this is an example. The NIL Foundation is working on this in EVM, Mina state verification. Sometimes we call it the Ethereum bridge. And so what that's doing is essentially taking the proof that we generate using Snarky.js and verifying it in an EVM smart contract. So when that's in kind of active testing at the moment, and so once that becomes available for developers to use, then you can verify the results of computation or apps, ZK apps on Mina in the EVM. So that will obviously open up a massive amount of possibilities for people to make interoperable apps between Ethereum and Mina. This is Open Mina, which is a full Mina web node that allows you to verify blocks, and you can submit transactions to the network through a node in the browser. So if you're creating a ZK app or you want to send a transaction, you can do it using this browser node without having to connect to some other third-party service, which you may or may not have to pay for. It may or may not be reliable. So that's something which is live right now as well. And I will drop a link to Open Mina as well at the end of this presentation. So these are things which interoperability and scalability, which we are working on bringing to users all the time. Now, I mentioned ZK apps quite a lot. I'm going to tell you a bit more about how it works. With Ethereum, the EVM uses on-chain computation. So the idea is you write a smart contract, you publish that, you deploy it on the Ethereum network, and then the nodes on the Ethereum network, when you call a smart contract function, they all run the same computation. And so in that way, you can be assured, right, that it's run because all of the nodes on the network execute the instructions at once. But that is costly and inefficient. And also you have to be very careful about how much computation you use, because you pay for computation with gas. So there's this concept of gas, which means when you do computation on the network, you pay for it, you pay these fees, right? And the more you use, the more computation you do, the more gas you pay. Now, ZK apps are slightly different. We use off-chain computation and on-chain verification. Now, what that means is you do the actual computation, you run the app off the chain, you run it in the client side, so you actually run it in the web browser client side, and then what you produce is you produce some state updates if you're verifying the on-chain state, and then you produce this proof, right? And then all that happens on the Mina network is that proof that you submit in a transaction, you verify that that's valid, and then it can make the state updates, right? So that's how a Mina ZK app works. You produce this proof at the end. Once you've called done your computation, you've run your ZK app, you produce this proof, which is the kind of output, and that gets verified on the chain. If it's not a valid proof, then your transaction gets rejected, and then the state doesn't update. So this has a number of advantages. One is that you increase privacy by keeping everything on the client side and only changing the on-chain state, so only exposing data as the only data that you're exposing are the public inputs and the on-chain state. So there's no gas fees. So all you have to do, you run your ZK app, all you have to do is verify this proof that you generate, right? And so you submit that proof in a transaction. So you can do unlimited computation and you just pay one transaction fee. The transaction fees are variable. So, but the point is, so there are fees, you pay the transaction fee, but the point is though, that you can do as much computation as you want and that fee stays the same amount, which is the current transaction fee for the network. There is composability and scaling using recursion, which is something that I will explain to you when we get to the section on Snarky.js in a bit. But recursion allows this kind of idea of scalability by you can batch things together and produce proofs of proofs. And it's interoperable because Mina has this concept of the succinct blockchain. So with a small amount of storage and computation, you can verify the state of the network. So those are the advantages. These slides are kind of more of a demonstration of how that process works. I'm going to go through them quite quickly, but remember that you can look back on these slides when we make them available. So essentially, when you kind of compile your program that you want to be the ZK app, you put the verification key onto the Mina network, right? And so your verification key that verifies whether someone has run your ZK app properly is on the network. People run your app, they submit the proof that they've run the app successfully with a transaction, and then that transaction is processed by the Mina network. So they check that the transaction is valid by verifying the proof that you submitted in the transaction with the verification key that you submitted when you deployed the ZK app. So in that way, there's a verification key in the network and users can generate these proofs using your program. Now, if someone tries to insert themselves in the middle and give you a false ZK app, then when it produces a proof, the proof won't be valid, because if only the code that you've compiled originally to create that verification key can be proven using that verification key. If any of the code changes, then the verification key won't work, right? It won't verify the proof that gets generated by different code. So this is a quick explainer about ZK app methods, which is what you need to know about if you are developing ZK apps. And so essentially ZK app methods have inputs and outputs. So you have arguments that you can pass to the method, you have some smart contract state, and you have some state that's external to the smart contract, which could be, you know, a database or some sort of value from somewhere. And then once you run the method, the outputs are you can update the state of the smart contract and you can update the state that you had that was external, right? So that's kind of the abstract representation of inputs and outputs for smart contract methods. So methods are written in Snarky.js. So that was a kind of conceptual overview of how ZK apps work. Snarky.js is the TypeScript library that we provide to make it easy for developers to build applications or ZK apps using zero-knowledge cryptography. Now, as I've just said, it's a TypeScript library, and it allows you to define, generate, and verify zero-knowledge proofs. Now, because it's TypeScript, there's good integration and provision of tools that you may already know and love, like NPM. We have good support for Visual Studio Code IntelliSense. So when you're writing code in VS Code or Visual Studio, it will give you useful suggestions, and you can kind of see what options you have available when you're using certain classes. We also have Prettier for formatting, ESLint, and Jest for testing, and they're all supported out of the box. Now, this slide shows you how easy it is to basically get started and deploy your first ZK app. There's 5 steps there. I'm not going to talk through them now. You can look at them again on the slides, and that kind of deploys an example kind of template app, ZK app. Now, I did mention earlier, though, that recursion is an interesting thing, which is a powerful aspect of what you can do with Mina. And so it says here, Snarky.js lets you define, create, and verify ZK snarks with infinite recursion. Now that means you can take a proof that you generate and you can use that as an input to another proof. So in that way, you can chain together proofs to prove things happened correctly and also happened in an order. So, or an ordering. The example that we've got on this slide here is a card game. And so player 1 can take their turn. So say you make a ZK app where you have to run the app according to the rules of poker or blackjack. Player 1 can take their turn, so they can run the ZK app. They can take their turn. They can generate a proof that says, I've played the game according to the logic that you put in your ZK app, in your program. They can then pass that proof to player 2. Player 2 can verify that proof, say, player 1 has taken a valid turn. Now I'm going to take a turn of my own. I'm going to make my move. So what they would do is they would include that proof that player 1 has done a valid turn in when they generate their proof. So then player 3 can get past that proof from player 2. They can see player 2 has taken a valid turn because I can verify that proof. But then I can also see that player 1's turn has been included in that proof as another proof. So in that way, you can verify, you can chain together these proofs, and you can verify that everything that has happened up to this point has been valid. Now, some of you may have noticed, right? That sounds a little bit like what happens on the Mina blockchain. So the actual layer 1 works in a similar way, where the state proof, the proof of everything, all the transactions and all the state that has happened up to this point, is actually included when one of the nodes on the network is building a new block and adding it to the chain. So it's this image here where you can kind of take a ZK snark and then you can include that as an input to produce another proof. So in that way, we're chaining these proofs together to give you a fast and easy way to verify the state of the blockchain up to now, or as I laid out in the example before, the state of the card game. So recursion is something that's really powerful. It's used to, that recursion is what provides this lightweight aspect of the Mina blockchain, but also as a developer, you can use recursion in any way that you want or can imagine. So someone recently at a hackathon used the recursive nature of proofs in Snarky.js and to come up with basically like a side channel payment kind of ZK app. So what he did was allowed two participants to lock some funds in a smart contract, and then you could go back and forth off chain with this participant, right? You could send each other tokens, right? Keep a kind of record of it and just use the recursive proofs. So you would only have to go back to the chain when you wanted to settle or close the channel, right? So that was something that was really cool and was you could implement. So you could do these completely off-chain payments, right, and not have any of it on the chain using recursion. And so you could, you could basically, using these proofs and verifying the proofs of the state that had come before, you could be assured that you could do these payments with another party. So I'm going to give you some updates now from the Mina ecosystem, and I'm going to tell you more about how you can get involved and what kind of things are available to you as a developer. So first of all, you may have heard of ZK Ignite. ZK Ignite is a program that we're running with the Mina Foundation, which is a kind of funding and grants program, but also we give support and kind of mentorship to projects which are selected to participate. We had cohort 1 is currently ongoing, and we've had some really cool projects come out of that. I'll tell you more about them in a slide that's coming up, but ZK Ignite cohort 2 is going to start in 2 weeks. So I think June 14th is the start date. So if you're interested, to give you some inspiration, we've got a couple of projects here. Anomics is a ZK rollup layer 2 solution, and they are building basically an L2 solution, which is going to be really useful for developers to build apps in a different way and also do storage as well. So that's something which is really cool. It's going to offer a lot of options for privacy and scalability to developers who want to build stuff on Mina. We have someone building the ZK app keyless wallet, and so they've basically combined some of these concepts like Shamir secret sharing and social recovery to basically say, if you lose your key for your wallet, we're going to make it available, some method available to you to recover that wallet basically. So if you want to read more about any of these, there's information about them on the ZK Ignite website. I can link you to that, but that's something really cool where without revealing your private key information or seed phrase, to third parties, you can kind of give them some information that you can call upon kind of to reassemble and recover your wallet at some point should you lose access to it. BioSnarks is a project that is using snarks with a particular focus on drug and biotech development to help data sharing and data validation. So that one's really cool as well, a bit more of an applied use case. So these are the kind of complete lists. I picked out a few there that I was particularly interested in, but 14 ZK app projects and 12 kind of developer tooling, which we were calling Dev for Dev projects, were awarded funding, and that totaled up to around 500,000 USDC, and there was also 300,000 or so Mina tokens allocated for grants for these projects, right? So you can read through some of them there. Obviously, there's quite a lot of information squeezed into those titles, but you can read more about them. They all have lots of information on the ZK Ignite project platform. So if you would like to get involved, there's the date that I remembered correctly earlier, June 14th. So it's in 2 weeks from now. You can get involved with ZK Ignite Cohort 2. That's a QR code there, which if you scan, you can go to the ZK Ignite sign up page. This will be made available to you, and we will link you as well to this. So don't worry if you miss it. But ZK Ignite, I highly recommend if you're interested to attend, sign up for it. The actual process takes place over a few weeks and even months. So it's not like you have to have a project ready to build on June the 14th. There's an introductory workshop. We encourage people to discuss their ideas, write proposals in a kind of draft phase and get feedback on them, as well as meet each other and form teams. So that's the June 14th is the start of the whole process. So don't worry if you've not done any preparation or anything. You can turn up on June the 14th and just get started then. So yes, that's a QR code. I'd also like to say that we now have a public roadmap available for Mina, the Mina protocol. And so we want to unlock the user-owned decentralized web using zero-knowledge programmability. There are 5 focus areas in our roadmap, including trust minimalization, ZK programmability, settlement layer performance, the Minaverse, and the road to DAOification. You can read more about them on the roadmap, and also it's interactive. So if you are a graphical thinker, you can mouse over things and see what stage we're at with things and what order we're hoping to tackle them in. Now, that kind of comes to the end of the update section. This is another QR code which takes you to a landing page. I think it's slightly out of date, so there's a competition on there which is no longer ongoing, so ignore that part, but there is a link to the getting started documentation, the ZK Ignite sign up link, the roadmap, and I think one other thing which I've forgotten, but it's all there. That QR code will take you to this landing page. Oh, the Mina protocol Discord server, which is where you can join, discuss, learn, meet other people. If you are a developer, we have our Q&A channel on there, and we run office hours on the Discord server as well, where you can come and meet Mina Foundation and O1 Lab staff and ask any questions you might have, as well as just generally hanging out and being part of the community. So I would highly recommend as well, if you're interested, to join the Discord server. So I'd like to thank you all for listening. I'd like to thank Nicole and everyone from APAC DAO and Phuc who have invited me to do this AMA today. So thank you for having me. Thank you everyone for listening. I hope it was useful. Again, we will make these slides available, so all the information you'll be able to look up afterwards, and we'll give you links as well to the Mina Vietnamese community on Telegram, and I think there might be a Discord channel as well. So thank you very much, and I believe there's going to be some difficult questions for me now.
Yeah, thanks Angus for sharing. Yeah, I actually really impressed with what Mina has to offer. So I think Mina has a totally different approach compared to like other blockchains that I know, that I think most of us are familiar with. Like instead of running and storing everything on chain, right? So Mina runs smart contracts on web browsers, and the programming language is TypeScript. So like no virtual machines needed. The learning curve for a new developer has been cut down significantly. But yeah, so Mina is still pretty new and has a very long multi-year roadmap that you share. So I'm still curious like how it's gonna work in the future. Uh, so yeah, let's find out today. If you guys have any question, please type in the chat box. In the meantime, I will ask Angus some question from myself and from the one that I collected before. The very first one that I'm curious is and this is a question that I collected from the community as well. Like, how does Mina protocol achieve a fixed size of 22 kilobyte while still allowing for the storage of DK apps on chain? Will the on-chain storage gradually increase over time?
The answer to that is yes. So the 22 kilobyte figure, first of all, is out of date. So I believe the state proof has come down now to 10 or 8 kilobytes. And it's important to specify what that means, which is for a single Mina account, you can verify the state of the entire chain. So the overall state proof, and you can verify the state of that individual account, which is token balance, so Mina token balance, and some ZK app state possibly as well. And so that 22 kilobytes, if you have, you know, so you can verify the state of your account essentially with 22 kilobytes, and you can verify that your account has a certain state, and then you can, here's the overall like Mina state proof, which is this string that I was talking about earlier with 22 kilobytes or slightly less in a fast amount of time. Now, the comparison to draw with that would be if you want to verify an account on a different blockchain, you would have to, in some cases, download the entire history of the blockchain and then like replay that state essentially, which takes a long time. So people talk about syncing nodes when they join the network. It takes a long time, it takes a lot of computing power, and it takes a lot of storage. Now, so you can imagine in future where, so this open Mina in browser node, right? You could run your own node in the browser that would verify your account, which is all you need, presumably, unless you're running some sort of infrastructure or service, and then use that to interact with ZK apps and the blockchain for your personal uses. And so from a personal level, you don't have to do this syncing operation and download the entire history. Now, as you've correctly identified, though, the data has to be stored somewhere, and so indeed the entire blockchain, right? So all the accounts on the blockchain, it's like however many accounts there are, n times multiplied by this 22 kilobyte figure, right? So there still is storage requirements, and there are a number of different roles that nodes in the network can take up, basically. So there are people who run archive nodes, which do store a lot more of the data. So if you want to run a block explorer, for example, you have to store all the transaction data that's in blocks, right? And so then you can run a block producing node which participates in the consensus and tries to build new blocks and add them to the chain using the Mina software. So there's various different roles that node operators can fulfill. And so that's another way that you can get involved, incidentally, is you can run a node on the Mina network. There's docs on our documentation website about how you can get started with that. So essentially, there's also a very small amount of on-chain storage, and those are basically that on-chain storage is stored in these nodes that run the network as well. So the node operators do have storage requirements. So there's a small amount of account state. There's this 22 kilobytes times the amount multiplied by the number of accounts, and then also the archive nodes store information for people to look up about things that have happened. But then if you're a ZK app developer, you can choose whether to access that data from an archive node. You can choose whether to make that available using some other storage solution that you want. So the data does have to go somewhere. But I think the thing to say about Mina is that it lets you as a developer have a lot more choice and flexibility about where you store it. And you don't just have to store it all on the network, which then results in these kind of giant blockchain sizes. So
I see. So in my understanding, right, there are like several types of nodes in Mina protocol. Like one can choose whether just to deploy a normal ZK app and use a 22 kilobytes to run it. And there is an archive node where the people like to have more data to run things like explore or something, right? So 22 kilobyte is just for a single like normal ZK app node. So it can run pretty much everything from that node. So I think it has something to do with the infinite recursion that you mentioned. So because of that, 22 kilobyte is enough because it already includes all the previous history up to that point, right?
yes. So the state proof for a block, like the Mina overall state proof, it actually has to do with using the recursion property. So including proofs and generating new proofs. So you can take two proofs, combine them into one, and then you can take two other proofs, combine them into one proof. You can take those two proofs that you've just generated and combine them. So the developers on this AMA may notice that immediately lends itself to the structure of a binary tree. And so what you can do is, so this is how it works, is you also have this other node role, which is a snark worker. And so essentially their nodes on the network will take proofs of transactions and then combine them all up, so we call it snarking. So you're combining the proofs of all these things into a tree, and then the top of the tree, the root of the tree, is this state proof. I'm not entirely sure. I think the overall state proof might also include some block like header data, but the idea is that you combine these transactions into this binary tree, and then some as well. If you've seen the architecture of other blockchains, you might have seen that they use a binary tree or similar structure using hashes, but this is using the proof instead of the hash. So verifying. So yeah, I'm not entirely sure. I don't want to get too far into like other blockchain architecture because I'm not really up to date with those, and I don't have such in-depth knowledge. But so you combine these proofs together, right, of the transactions, and then that gives you this overall state proof, right? And so again, it's that idea of because you can use a proof to generate a new proof, then you can chain them together like that, and you can end up with this one proof at the end that actually has all these proofs as an input to it. So you can, if you have the if you have your transaction and the path in that tree, then you can verify it very quickly, right? Using the overall. So that's what that 8 or 10 or 22 kilobytes is as well. It includes the path in that tree. Of proving.
The path in the latest state, right?
Yes.
And I also I like the example that you share about the card game. Actually, I have similar ideas about how to implement these kind of like poker games on chain. But back then there's no such thing as DKP a few years ago. So this is a very interesting approach that I can take from your presentation. Here comes the second question. So since the smart contract are stored and executed in browser instead of deployed on chain, right? So what if someone tried to attack and change the logic of the approval function? Is this gonna cause any problem to Mina proof system?
That is a good question. So because when you do when you deploy your ZK app, it does this thing. So you compile the code. So you write a ZK app with some logic in it. You compile the code. So then you create you produce the verification key.
Right? Yeah.
And so the verification key, and you also produce the what's called the prover function. So that's the outcome of this kind of you put your code in, you produce this thing called the prover function. Now it also, you produce this verification key, and then when you deploy the ZK app, the verification key gets associated with the ZK app account in the Mina network. Now you can't change that verification key unless you have access to your private key that you use to send transactions from that account, right? So you can't change the verification key. Now the verification key and the proving function that come out of the compilation process are linked. And so if someone tries to use different code or change the proving function in some way, then it won't generate proofs that will be valid using this verification key that's in the network. So in that way, the only way that, and then these are nodes on the network, right, that are verifying the proofs that get submitted in the transactions. So then you have this, the consensus and the verification of the Mina network, right, verifying that the proofs are correct. So if you change the prover function, it'll generate an invalid proof. And then if you submit a transaction with an invalid proof in it, the consensus and so the network nodes will reject that transaction because it's invalid.
I see. Yeah, got it. So like when I deploy a ZK app to Mina, right? Actually, I will compile the ZK program and then produce a hash, like a key, right? So if I change the approval function, I actually changing the key. So it's going to be different compared to the one that I deployed to Mina protocol. So the output that I give to the verifier will be different and cannot be verified,
right? Maybe. I think so. Could you repeat the question for me, please?
Like if I gonna change the approval function intentionally, so basically the output from like the output cannot be verified with the same hash that I submitted to Mina protocol, right?
Exactly, because the verification key
It's different.
is the same. So if you change the prover function, you need to change the verification key as well for it to work.
Yeah.
And so as a ZK app developer, if you redeploy your app, then you change the prover function and the verification key. If you change one of them and not the other, then it doesn't work.
I see. Got it. Let me pick a few questions from the chat box. Here's a question from Joseph. Hi, Angus. What's the difference between Mina's ZK Bridge and others, such as Rainbow Bridge from Near Protocol? I'm not sure if you're familiar with Rainbow Bridge or not.
I am not familiar with Rainbow Bridge, but it is possible. It is something that I will be looking up after you've mentioned it, Joseph. So thank you.
In that case, maybe you can just like introduce a little bit about ZK Bridge for Mina protocol.
Yes. So what we are calling the ZK Bridge is actually that thing that I showed you earlier, that web page from the Nil Foundation. And so that was actually work undertaken after a joint grant from the Ethereum Foundation and the Mina Foundation to provide interoperability between the Mina blockchain and the Ethereum blockchain. In practice, what that means is if you can verify the proof that Mina generates using the proof system that Mina uses on Ethereum, then you can prove the whole state of Mina. So you can prove that transactions have or haven't taken place, and you can prove things. You can prove the validity of staked updates that ZK apps have made. So that then becomes at that point Mina becomes a kind of ZK execution layer that you can use on Ethereum. So you can generate proofs, you can build ZK apps that will run in the browser for your users, and they don't have to pay gas costs for computation, so they don't have to pay more for the more computation they do. And then all you have to do is send that proof, you know, get that proof into an EVM smart contract somehow and verify it there. So as I said, that work has been ongoing and it's in the kind of testing phases. The other side of that would be, can we, you know, verify an Ethereum transaction or block header in Mina, right? And so if you have that two-way communication between the blockchains, then you can start building things like, you know, bridges, cross-chain apps, things like that. So what we mean when we say ZK Bridge is this idea of verifying the proofs between the two chains. I think other like applications like token bridges where you go to an app and send things from one chain to the other. There are apps that are built on top of this layer that we're kind of working on now.
In that case, can we consider like, I mean, once the ZK Bridge or the in-EVM projects has been done, then can we consider Mina protocol as one of the roll-up solution for Ethereum?
That is an interesting question, and possibly. It depends how you define roll-ups, and it depends how you define Ethereum solutions. But what I will say is, there's certainly a situation that I could imagine if we do get this EVM verification Mina state working reliably and well enough for developers, then you could, as a developer, build an application using Snarky.js that would, you know, allow people to do some allow people to play a poker game or do some voting or sign some messages. You could verify all of that. You could roll it up using Mina, so you could generate proofs of all these different things. You could combine that into one single proof, which, again, it depends how you define rollup, but if you're taking all this computation or all these transactions or outputs, you combining them into one single proof, I would say that counts as rolling them up, right? So you roll them up into one single proof, then you take that proof into the EVM smart contract and you verify it on Ethereum. Then I think you could say that sounds a bit like an Ethereum rollup solution, but it just depends, again, what your definitions are.
Yeah, I see. Yeah, but I think both Ethereum and Mina is the like one. Then it could be something like sidechain or just like cross-chain solution for both chains. Yeah,
Precisely.
Yeah. Another question from the community. Do you perform any load tests to prove the TPS, and how can we measure the TPS while the execution environment doesn't run on chain?
That is an interesting question. So it depends what you define as transactions, and there's the current state, the current reality, and then there is the potential for things in future. That are two things that I'm going to talk about. The block time and the baseline TPS at the moment for the actual Mina network, I'm not entirely sure of. And I'm not sure if there's load testing, but that would be an interesting thing to find out. And there's a lot of people who are very enthusiastic and helpful, who are involved with running the nodes on the network. And I think if you asked in the Discord, then they would be able to tell you if there's data like that about load testing. One of the things about TPS is it's kind of an aggregate figure that you know means different things in different situations. But one of the things I can say is if you have a high throughput application, then there are ways that I could think of where you could basically if you can offload some of those transactions into an off-chain solution. So, for example, a kind of an L2 roll-up type thing that publishes state updates every block. But basically, if you have two people who need to do a lot of transactions between each other, or a number of people who want to do transactions with each other, you could basically kind of design an L2 looking situation, which would allow you to do very high TPS with Mina. And that just basically comes down to the idea of doing this rolling up of things, right? So taking transactions or updates and combining the proofs together into a kind of a single update, right? So that's one of the ways that Mina offers you scalability, is this idea of combining the proofs together because of recursion. And essentially you can kind of run, I kind of describe it sometimes as build your own L2. Of course, if you don't want to build your own L2, there are other people currently doing that at the moment, building various L2 designs for Mina. So you can achieve large, scale, you can achieve large scalability using Mina, and it works by this idea of combining the proofs together or rolling up as some people understand it.
Got it. I think comparing to other blockchain, then because most of the execution is done off chain, then definitely Mina protocol will save a lot of computation on chains already, and that's also one of the reasons that you guys have a fixed gas fee, right? It's a way better and more predictable than other line one. I will have another question. Let me choose from the community, from the chat box here. This one is not very technical. So regarding the UI, only web UI is mentioned in the documents. How about mobile app? Can we interact with ZK app for mobile application?
That is a good question. And I think the answer is, at the moment, no, because ZK apps require aspects of a full web browser that I don't think, I think maybe it was possibly only on Apple that hardware that ZK apps won't work. So but I'm not sure about mobile apps. I think there's something. This is a good question though, and it is something that I will check up on. At the moment, it's only been people doing browser-based apps.
Okay, you guys,
so,
if you have a similar question like this, maybe you can ask them in the Telegram group that Raz has pasted in the chat box or in the Discord. And I personally think that because it's a TypeScript library, Snack.js, right? Snacky.js, then many applications in mobile, they are implemented in TypeScript already. Like you can build a TypeScript in mobile, like in React or Flutter, and all of them use TypeScript. So possibly Mina protocol will support it in the future. So I have another tricky question from Victor. My question, Victor question is, since the execution environment and state is basically off-chain, how does Mina handle racing condition? For example, there's two running ZK app are running and modifying the same state.
That is a good question. And so the execution environment is off-chain, and the state, there's a small amount of state on-chain. And so that's the state that you can change using your ZK app. So what a race condition is when you have unpredictable behavior depending on the order of things happening in a computer program. So if you have two different possibilities based on which thread gets finished first, which can be unpredictable for a whole number of reasons at this kind of programming level, then the program basically might have unpredictable behavior, which isn't what you want. So that's why it's called a race condition, because it's like whoever wins the race gets there first and then changes the value somehow, and then that could have knock-on effects for everything in the app, right? So with Mina, there are certain so there's ZK app updates get included in blocks, and there is a block time. So if there's two different people trying to use the ZK app at once in the same block, then you can run into race conditions. Now, it's quite a complex subject. I'm trying to think of an example off the top of my head, but essentially, it depends on how you build your application, and that is something that you kind of have to take into account as a developer, is thinking about concurrency. Now, there have been a number of approaches identified to tackle the concurrency issue, one of which is using account updates, which is a way to kind of order these sorts of updates that are happening. And another is when we're talking specifically about the state, there's been a number of ways identified to store state off chain but have some sort of link back to the state on chain, so that you can verify things and kind of change them and be assured that the data, you know, hasn't been modified. So there is a storage solution called ZKFS, which is essentially kind of on chain storage, state storage. It's not really on chain, the data is off chain, but then there's a kind of link back to the on chain state. So generally it involves storing like the root of a Merkle tree and then tying the state that gets stored off chain to this Merkle tree in some way, so that when updates, like state updates, happen to this data, then that gets reflected in the on-chain state via modification of this Merkle tree. So in that way, the kind of the state has been talked about, and indeed there is a way to use what's called a sequencer. So another way to tackle this issue has been to basically kind of build an L2 type, you know, go above the protocol layer and use a sequencer that kind of handles the concurrency issues, like the race condition thing. So it will order the transactions or the updates, produce an output proof, and then submit that to the chain, the L1 chain. So that's a way as well that kind of people have been dealing with it, is taking the concurrency to the next kind of layer.
I see. Got it. Yeah, I think this is a very complex topic, and dealing with the concurrency in blockchain is difficult. I think that's also why Ethereum EVM is single-threaded, no concurrency. So as we are running out of time, I think I will have like the last one or two questions. Then I will hand over back to Nicole. Here's a like general question for Mina protocol. What's the biggest hurdle for Mina to be widely adopted?
That's a good question. I don't really see these things as hurdles. I see them as opportunities. I think there is nothing stopping any of the developers here from getting involved and signing up for ZK Ignite and building amazing ZK apps. And I think that's probably what we need to achieve wider adoption, is having people building applications which people can use, to testing out the network and finding ways to improve it, and kind of getting involved, growing the community, and telling, you know, users, other developers, people who are interested about Mina, and getting them to join the community. So I think that's something that we can all be a part of. expanding and kind of achieving wider adoption.
I see. Yeah, thanks, Angus. Here's the last question. So in Vietnam, there are a lot of GameFi projects, and here's the one that's relevant to gaming. Could you share a bit about the combination of DK apps with gaming in the near future? And how does like Mina protocol support GameFi projects?
That is a great question. So first of all, I have met several people, and I do know that there's a big GameFi scene in Vietnam. So that's something that I'm really excited about. I think as that slide with the card game on it shows, the idea of doing kind of off-chain recursive proving and being able to verify that on-chain again at any point is a powerful kind of design pattern for people who are building games, especially that are turn-based, to provide gaming experiences like blockchain, not exactly on-chain, but blockchain gaming experience to people without the constraints of actually doing the computation on-chain. So that's something that I think could be really compelling for game use cases. I think there's no reason why games couldn't be considered for the ZK app track on ZK Ignite. So I would say if anyone was interested in building games or building infrastructure that could be used by games, then you should absolutely submit a proposal for ZK Ignite cohort 2, and then you will have this kind of support and mentorship from the community, and also some funding to help you build your project. And also, I would say there have been a few people who have done some cool things with games using ZK and using the kind of idea of having things be trustless, and some things that are a bit more cool to do with the kind of crypto side. So things like someone built a battleships game that allowed you to kind of play the game of battleships and trust that the other person hadn't cheated and kind of lied about where their ships are, but then you could still play a fair game of battleships. And there were some people who most recently at this hackathon we did in April built a kind of a Risk type game, and they fit the entire state of the game into one field, kind of one state variable. So there are some people doing some really cool things to figure out how to provide gaming experiences. Another thing which might be useful to game developers is providing kind of trusted or verifiable randomness, or things where maybe, for example, if you have a map and you want it to be covered with like, fog of war or something, there's ways to kind of keep some of these things hidden for players without having to trust that, some server somewhere or some person is giving you something that's fair, right? So these are the kinds of ideas that I think could be interesting to people building games as well. Yeah, thanks for the suggestion about the use cases for the gaming projects. And if you guys have any other like ideas, please check out ZK Ignite cohort 2. I think that's very much everything from me. Hand over to Nicole.
Okay, thank you, Angus, and thank you for spending your time today. I'm pretty sure, people would have a lot of takeaways, from this session. Do check out the links on the chat box, for Mina Protocol Vietnam community, and also a Discord channel for ABC so that you can stay updated with the upcoming sessions. And very importantly, we're going to be able to see Angus in person in 2 weeks. So he's going to be at Bureau Vietnam from June 16 to 17 in Ho Chi Minh City. And I hope that you guys can also come join us. I'll just drop the link in the chat box as well. We're going to have like, you know, very interesting sessions, training workshops over there for our developers and builders. So looking forward to